Hey, and welcome back to part 2 of our tutorial on Scratch custom blocks, also known as My Blocks. Back in part 1, we learned how to take a group of blocks that perform a simple function, drawing a triangle, and use them as a recipe to create a brand new Scratch block that we can use to do the same job over and over again without having to make copies of our code. In today's lesson, we're going to add some new components to our custom block that will give us more control over how we draw triangles. So you'll be able to decide how many triangles to draw and how big they can be just by typing numbers into our custom block. Let's get right to it. So I'm back inside the file I was working on last week called Drawing with Custom Blocks. I'll be sharing that file out and putting the address down inside the file description if you're interested in having a look at my code. So what we did last week, just to review, is I made a custom block here called Draw Triangles that will draw a number of triangles across the screen here. In this case, I've got it set up to draw 10 triangles, and when I click the green flag, you can see that it generates 10 triangles in random locations across the screen. Now, one of the features I showed you in part 1 was this extra little parameter that's called run without screen refresh, and when that's selected, it speeds up the drawing process so that it all happens behind the scenes and your drawing basically happens instantaneously. So what I want to do today is build on this draw triangles block and give it the ability to add some more details about what our triangle is going to look like. So in addition to having the word draw triangles here, we're going to create a little bubble on the side that tells us, for example, how many triangles to draw on the screen. It's really not that difficult. Though when you look at the actual menu for drawing custom blocks, it's not immediately obvious how they work. So these three options here are the ones we're going to be addressing today. They call them inputs in Scratch, and they definitely are inputs. They're places where you can put information into the block to tell it how to function. These bubbles that create information, you'll find them all over the Scratch interface. Like here, where I'm picking a random number, you can see that I can enter information to tell the pick random block how to function. We want to do the same thing with our draw triangles block here by adding some of these inputs. This one on the left here called add a number or text input is the most important one, and we're going to be using that quite a bit here. So we're going to add a little bubble here right next to, we're going to want to add a bubble right next to this that has the number of it. Now we're going to want to edit the text a little bit though, so because we want people who are actually reading this block to be able to understand what's happening here. So if I go draw triangles with a blank after it, people who look at this code aren't necessarily going to know what information to add in that blank. So I'm just going to make it a little bit easier by changing the wording of this a little bit. So I'm going to go draw, and then I'm going to add a bubble right next to it. So I'm going to click on this Add Input button, and you can see right here, now it's asking us to label what the information is inside of this. So I'm just going to type in how many. This isn't going to be visible in the final block. It's just going to be draw and then a blank bubble. But if you look at the underlying code and you're trying to figure it out, this is kind of like a little notation that's going to help people who are looking at your code in the define block figure out what this parameter does here. All right, so draw. So we're going to go draw blank, and then we're going to say triangles after that. So I want to add a little bit of extra text to the end of this, and we can do that by clicking on this block here that says add a label. So I'm going to click there, and you can see I have a different shaped hole here where I can add some extra text. So I can say triangles here. There you go. And as soon as I unclick that, you can see it's turned dark red, like the word draw, to emphasize that this is what the actual block is going to look like. Okay, let's click OK. And now you can see our block has changed shape. Now I have draw blank triangles. Now if I enter a number into this right now, nothing's going to happen because Scratch doesn't know to take this number 2 and actually do anything with it. Let's go back to the original triangle drawing code, which is right over here. You can see that it determines how many triangles to draw within this repeat loop. If we repeat this loop 10 times, we're drawing 10 triangles. So that's how many triangles we're drawing. If you look at the define block here, where we added that little hint text, it says how many. And if we pull on this middle part, it actually forms a little bubble, just like that we can actually insert into our text. So we're going to want to put, every time we add one of these inputs here, we're going to want to tie this to our code somehow to tell it how we want it to function. So in this case, how many is controlled by how many times we repeat here. So I'm going to grab this how many function here and drop it into the repeat loop here. Now when it reads this code, it's going to say, it's going to proceed through the code here, and when it gets to the point where it wants to repeat, it's gonna see this parameter here and see how many, and to figure out that number, it's gonna look at what you drew inside the block here. So in this case, I've got it drawing 2 triangles. Let's erase our screen right now, and I'll just add this block to our main code here, and you can see that I'm drawing 2 triangles here. Beautiful. Now let's try drawing 100 triangles, and you can see it'll go around the loop 100 times. Great, so there we go. So that wasn't too complicated, was it? So what we want to, the benefit of this, I mean, you can always go into the code and modify the number that repeat. The nice thing is that we can continue to use this over and over again. Let's say I want to draw 100 triangles now, and then later on in the program I want to draw 10 triangles. I don't want to, if I wanted to do that using this current structure here without the how many, I would have to go in and make a different copy of this each time that I wanted to draw a bunch of triangles, and each time I would need to run that inside a loop with a different number of times in it. Now I've saved myself the trouble, and I can redo this as many times as I want to have it draw this many blocks. Now this isn't particularly useful because we could just do 115 blocks instead of drawing 110 and 5, but usually in your code you're going to be doing a bunch of other stuff after you do this function, and then you're going to call it again, and then you're going to do a bunch of other stuff, and then you're going to call it again, and that's where it becomes more useful. All right, so you can take any part of this process basically and automate it by adding it to this define block here. So for example, let's change the size of the blocks that we're drawing. You guys might remember from last week that we defined the size of the triangle here right in this move 50 steps block here. So what the script is actually doing is putting the pen down and dragging it across the screen for 50 pixels, then turning and then dragging it 50 pixels across the screen in a different direction, then doing the same thing again the last time. And so if we turn this into a parameter, then we can control how many blocks we're going to, how many pixels we're going to move across the screen. Let's go ahead and edit our block to do this. So we're going to try and reword this in a way that makes sense so that when we're coding it, we'll be able to very quickly see what number it is we have to enter there. So we're going to draw blank triangles, and right after that I want to say, so I want to really say draw 5 triangles at size 50. So I'm going to edit this existing word triangles here and just add the text at size. And then right after that, we're going to add another bubble. So let's go ahead and add a bubble here. Beautiful. You can see there's a little trash can at the top here, which you can click if you accidentally add a piece that you don't want to add, that you want to get rid of. There we go. So let's add a little word hint here that will tell us what's happening here. I'll just type in size here, and that will make a little more sense for us when we're coding it. Okay, let's click OK. All right, so we want the size bubble that's created here to go into this spot here where we are drawing our size at 50 steps. So once this happens, now my block has 2 slots in it, and here I can determine the size of the triangle. So let's draw our triangle at size 20. There you go. And now we can start to see how this block is going to help save us some time, because now we can control two different features, and we can run this script 2 or 3 times at different settings here. So let's draw 10 triangles at size 20. Let's draw 20 triangles at size 10. And we'll draw 5 triangles at size 50. And you can see how quickly I can do that without having to do any additional code. I just have to add this information. And now I'm going to be drawing 3 different kinds of triangles across the screen at different sizes. Beautiful. So in addition to being able to add numbers here, you can drag in any oval-shaped block. Since this is an oval-shaped hole here, you know that in Scratch we can take any other kind of block, like for example a pick random number block, and drag it into either of these slots here. So in this case we can draw a random number of triangles. Let's go between 1 and 100 here. And you can see when I click the green flag, we're going to get a different number of triangles. That was only 3, it looks like. Different number of triangles each time we invoke this code. Excellent. And so depending on what kind of script you're doing, you can add variables into this, for example, or even do a little bit of math, like a number plus a variable or something along those lines. So we've created a very powerful little block here that basically functions the way that any other Scratch block with bubbles in it does, where you can change those parameters by just typing some numbers in. So there's one input that I haven't talked about, and let's just draw a little test block here just to show you what that looks like. So I'm going to go make a block, and we'll just call it test for now. And I'm going to add this middle input, which is called a Boolean input. So let's click on that and see what that does. Let's go OK. So now I have a new block here that has a different size hole in it. This doesn't take text information, it takes Booleans. Now, what's a Boolean, you might ask? A Boolean is a computer term for a piece of information that you can either switch on or off. So an on-off switch is an example of a Boolean, and it only has 2 possible states to it, on or off. And so anything where there's a yes, no, or a on, off, or a true, false kind of choice in it, that is a Boolean input. Now in practice, now you can shove any block, again, with this shape into here. So we can take comparators like greater than or equals to, and pop them in here just like that, or even combinations of it, not equal to or and equal to a different value or something, for example, and pop that into the hole as well. Just anything that ends up with sharp edges at the end can be dropped into this spot. Now, where is this kind of Boolean operator useful? That's an interesting question, and in all my scouring of Scratch wikis and stuff like that, I never found a lot of really good uses for this Boolean. It's nice that it's there, but in practice you're not going to use it very much. The limitation here is that whatever we put into this block here, we can change what's being compared to, but the actual custom block is always going to do the same thing or not do the same thing based on whether that's true or not. So the define block inside of this is going to end up being basically an if-else statement. If whatever's in the test here is true, let me show you an example here. So I've modified this test block and added a bit more information to it now. It's now an if-else statement that speaks the word true if what's being compared is true, and false if what's being compared is false. Right here in the top of the if statement, we have to drag this Boolean, because whatever it is that gets compared here is going to get plunked into this if statement here. So let's test this out here. I'll say if 1 is equal to 1, which is obviously a true statement. Let's click on this.
True.
My computer says true. If I ask it, is this true? 0 equals 1?
False.
There we go. So this is working exactly the way it's supposed to, but again, I'm not sure what the function of this is supposed to be or how this would help us out in coding, really, because really we can, every time we use this block, we can compare a different thing, but in the end, it's always going to spit out the same information. It's going to say either true or false here. And so I'm not sure how this is actually going to help make our code more efficient. I scratched my head and did come up with one example though, which I'm hoping will shed some more light on this. So let's have a look at that right now. So I created a brand new Scratch project here called Custom Blocks Booleans, and you can find the description down in the links below again. And what I've done here is I've recycled some of my graphics from a lesson I did a little while ago on health bars. And basically this is a bunch of costumes inside this health bar that makes it change. When we get to costume 1, it becomes 10% full, 20, 30. And once we get up above 50% on costume 6 here, it turns yellow to start warning us. And then we get to 8 where it's red, and 9 where it's red, 10 when it's red. And then once we get to 11, we have a state where we've broken our meter. And so I've just drawn a couple of little scratches across it to suggest that the meter is broken. So we can use this to kind of create sort of a Homer Simpson style nuclear reactor gauge system here, and have them randomly go up every couple of seconds, and to suggest the fact that all these reactors are getting hotter and hotter. And you can see they're changing costumes at a random time here until eventually they're going to get up into the yellow. There we go. And then from there they go into the red. And I want, at key moments during this process, here we are, we're red, I want to ring an alarm bell. So we're testing for different numbers. We're going to do a threshold at 6 when it first turns yellow. And then we're going to do another threshold at 8, 9, and 10, which is every step of the red state here. Oh, we've broken some reactor things here, and we're in full meltdown now, which is not good. So, so this kind of fits the bill for adding a custom block with a Boolean parameter, right? We're checking a bunch of times here for different numbers, which are the different thresholds we're going to hit. But every time we hit that threshold, we want to do the same thing. So I've added some code here that does this without the custom block, and let me show you what that might look like. When we hit a certain threshold, if our costume number is equal to 6 or 8 or 9 or 10, we're going to say the temperature is that number, whatever the costume number is, so the temperature is 5, and then we're going to play an alert sound. And if we aren't at one of these numbers, we're just going to enter a blank here, which is going to get rid of the text bubble that says what the temperature is. I'm going to drop this inside of the first if statement here that's picking a random number. So as soon as we pick a random number, we're going to compare it to this list and see if it hits any of these thresholds. I've added a second if statement here, which I'm going to put inside the main if statement and parallel and below to the other one. And that's, if we get too far, that's going to play a different sound, which is smashing glass. And it's just going to stop the script from running for that particular one so that it doesn't try to go to costume 12, in which case it's going to start all over again with a blank and start moving up. So we do want to stop that part of the process. Okay, let's run this now and see what this is going to look like. So our temperatures start to go up, and once they hit that threshold of 6 is when we're going to get our first alert sound, and it's going to and the computer's going to tell us what the temperature is inside that particular reactor. There we go. We've just hit our first threshold. You can see how it said the reactor is at 6, and this reactor 3 has just gone to 6, and hopefully, and reactor 4 as well. So one of these is going to hit 7 at some point. These have all hit 7, and now they've hit 8, so they've all turned red now. 9, and then 10. Now this guy's going to break in a second here. He's going to hit 11, and then he's going to break, or one of them is anyway. There we go. Our first one is broken here, and you can see this one's not moving anymore. Okay, so this is a suitable candidate for a Boolean custom block. Let's have a look at what that would look like. I'm going to disconnect this code here, and I'm going to show you the new custom block that we've created here. So instead of a bunch of if statements, I've created a Boolean block here that says temp check and then has a blank here. And so what we're going to be checking here is if the costume number is equal to 6, or if the costume number is equal to 8, or 9, or 10. And we can put as many of these as we want in here, though each time the output is going to be the same. We still need that second if statement here that says if costume number is equal to 11, play the smashing glass sound and stop, because we can't account for that in our define block. Let's have a look at the define block here. So if Boolean, then we do that function, which is play the alert sound and say the temperature, and say blank otherwise. So we've just tidied up the code a little bit, and it basically performs the same function here. We're just going to skip ahead in time until we get to threshold 6, and then we'll confirm that this is working properly. There we go. So our temperature hit 6 and hit it again here, and you can see that our code is working exactly the way that we want it to. So I don't think we added a ton of efficiency here, but we did make it clearer what's happening in the code, whereas when I look at this, it's a little harder to read and a little less clear. And there certainly are cases where this would be helpful, but mostly I don't think you're going to be using Booleans in custom blocks. The real power of custom blocks is in these text or these inputs that allow you to put text or numbers into a block. So once you understand how to use these inputs properly, you've unlocked a tool that can really add immense efficiency to your coding process. You can create custom blocks that perform all kinds of functions, and it's really only limited by your imagination. If you want to see an example of all kinds of custom blocks in action, I'd recommend you have a look at my digital storytelling toolkit, which is available in Scratch, and you can find the link down below in the description. So this toolkit contains all kinds of blocks that you can use in your digital story projects. Blocks that make your character fade in, fade out, shake, jump across the screen, or throw things across the screen, and all kinds of other really cool functions. I've coded the Scratch file with a little animated tutorial that will explain how each of the blocks work. So to deploy these blocks inside your own project, you simply have to take the define block, the hat block that has all the instructions for how this block works, and drag it into your backpack, and from there you can deploy it inside your projects. Hope you have fun with that. If you make something cool with custom blocks, please share it with me. I'm Mr. Tomec on Scratch, and I'll be happy to show your projects on my weekend live stream Saturdays at 10 a.m. on YouTube. See you there.